Hello, my name is Hanjun, and this is Physics 2211 Lab 3, Black Hole. Here are the table of contents that I'll be going through today. The purpose of this lab is to find the mass of the black hole and then use the mass to find the initial speed of the spaceship needed to avoid being sucked into the black hole. And here are the preview of the results. Here are the fundamental principles used in this lab. I used Newton's second law, force of gravity, and centripetal force. With Newton's second law, I also used the formulas associated with it, such as the momentum update formula and velocity and position update formula, which this will mainly be used in the second part, while the momentum update will be used in the first part. Some initial conditions and assumptions include that spaceship is a system and spaceship has initial velocity in part 2. And assumptions include force of gravity is the only outside force present to whatever system we choose, since we're in the setting of the space. Procedures. I first use a given glow strip starter code to calculate the mass of the black hole by using the momentum principle to divide that into perpendicular and parallel net force. And then I use the mass from the first part to make the spaceship not crash into the black hole by using the guess and check method on spaceship's initial velocity based on the mass of the black hole. Then we discuss the results from both parts of the code. Part 1. Here are the initial conditions of the code. So in this image, we use the momentum. Actually, in this image, we use the momentum update formula to get the momentum, and then we use momentum to find perpendicular and parallel components of the net force for the arrows on the graph, and then I use the centripetal force is equal to mv squared over r to find the black hole's mass. Part 2. Here are the initial conditions again, and in this code I'm calculating I'm isolating the systems to get different components of the force acting on the spaceship, and then I use the velocity and position update formula to find the ship's trajectory used in the graph, and then through the guess and check method, my initial speed come out to be negative 1e7 1.032 e to the 7th meters per second. Some potential errors include that guess and check method of the initial velocity of the ship is not the most accurate for the minimum speed required not to get sucked into the black hole, and assumptions of no other outside forces acting on the same ship does not represent the reality. Additional questions. What does it mean? The momentum update principle are different from the parallel and perpendicular components of net force because they are simply different formulas. So dp dt only requires you to know the system's mass and change in velocity and time, while the parallel and perpendicular components of the net force requires you to know all the forces acting on the system, which means that you need to know all the forces formulas and direction and whatnot, so making it theoretically harder to use, but also obviously different scenarios requires different formulas. And what if that we needed to stay in the orbit, black hole's orbit, but can't be sucked in? So again, we'll use the guess and check method so that the spaceship's trajectory will stay in a circle. So the initial velocity came out to be 0.07 e to the 7, 1.05. Actually, this should be negatives. Typo. 1.05 to the e to the 7 meters per second. Thank you.